multi-sector infrastructure demands. That's why at JK Cement, we have crafted our strategies with vision and executed them on a scale that defies imagination. From our mines to our factories, resources and operations are streamlined with the help of cutting-edge technology to address India's rapidly growing cement needs. We are preparing for tomorrow by thinking ahead, identifying needs and building a future-ready business.
We believe that market share follows thought leadership. Therefore, we have always placed significant premium on thought leadership and challenging convention.
Backed by the strength of the JK organization, we have grown from a single cement factory in Rajasthan 4 decades ago to over 8 high-tech plants producing grey cement, white cement and multiple specialized building products. We are amongst India's largest cement manufacturers with a capacity of 10.5 million tons of grey cement and 1.2 million tons of white cement, employing over 2,800 people across 46 offices. Our portfolio also includes diverse specialized building materials, including wall putty and value-added products such as Primax, Super Grip and waterproofing compounds.
We've consistently expanded our capacities, market presence and product profile. Our focus is on creating value for all our stakeholders.
With high-impact marketing and advertising, JK Cement's brands enjoy strong recall in the minds of consumers and retailers alike. Our brand's visibility and goodwill is a key driver of our business. Our grey cement has strong penetration in the large Indian market, primarily in the north and south of the country. Our white cement business is a strong differentiator, being not only a national brand with a pan-India footprint, but also an international presence. We export white cement to several countries in Asia, South America, Australia and Africa. To cater to the global demand, we have also set up a white cement plant in Fujairah in the United Arab Emirates.
The Fujairah plant gives us a strong competitive advantage by opening out new and attractive markets internationally and putting us in a global leadership position.
We have implemented some of the most sophisticated technologies and control systems to ensure our cement is of the highest standards. But our true strength comes from our people. We find, nurture and retain the best talent, and they give us the courage to push frontiers. We are equally focused on working with communities around us to help create a meaningful difference in their lives.
As a cement manufacturer, we have a direct role in nation building. Nation building cannot happen without proper education.
From building facilities that offer top quality modern education to enabling access to vocational training, we are driving skill-based employment and helping empower women. We have also partnered with government bodies and NGOs to provide healthcare to both children and adults. Our business is constantly guided by responsible growth, which means creating a safe and sustainable foundation for a better tomorrow. We have relentlessly enhanced the use of alternate fuels in our manufacturing process. Being a part of an industry that consumes large quantities of water and energy, we have taken several measures towards water recirculation, increasing water efficiency and rainwater harvesting. We are amongst the first companies in India to have captive power generation facilities running on both thermal and waste heat recovery technology. We are consistently investing in capacities and higher efficiencies to become a major contributor to the Make in India campaign.
With over 10 million tons of capacity in grey cement and nearly 50% market share in white cement and wall putty, we are on a strong wicket. We will deliver superior value to our shareholders and keep expanding.
We are confident of growing our grey cement capacity by 30% and our value-added products by 50% in the near term. JK Cement is at the vanguard of India's cement industry, and we are helping build a robust foundation for a newer, safer and stronger India.
Bekir Pekmezci. I have been working as an associated professor at Istanbul Technical University. In addition, I do work on the boards of some production and R&D companies in the building materials industry. Today, I'm going to be talking about Turkey construction materials industry during COVID-19 pandemic. And I'm going to be giving some foresights for post-COVID-19. My outline will be Turkey's COVID-19 cases in the beginning and now. And I'm going to be talking about the importance of Istanbul for industry and for materials industry. Some indexes of building materials industry in Turkey during pandemic and concluding remarks and post-COVID-19 foresight. This figure shows the number of COVID-19 patients in Turkey with time. Looking at this chart, we can say that the outbreak in Turkey has two critical points. The first of these is between March and May. The second is after October. Between these two critical periods, the pandemic remained at a steady rate. We will discuss the effects of these two periods in the next slides. The information of the slide is published every day by the Republic of Turkey Ministry of Health. For example, November 16 was taken from the report that shows the distribution of patients in Turkey. We can say that the number of patients in Istanbul on the mentioned day is 26% of the number of patients in the whole country. This rate reached up 65% in March-May period. Why Istanbul is important for industry? Istanbul is the center of economy in Turkey. Many production facilities are located in and around Istanbul. The structure of Istanbul causes easy spread of the virus. During initial period of pandemic, people movement to the other cities from Istanbul was restricted. Although the movement of the goods were free, construction industry requires site visits and surveillance during application of the materials. Especially technical teams of the producers was not able to visit the construction site. Moreover, construction sites stopped the work to prevent the spread of the virus. Some of the construction sites decreased the number of workers. This caused the increase of timelines of the constructions. Due to these limitations in construction business, construction professionals started to discuss future of the industry. This slide shows the ready-mix concrete index. Values show the increase to previous years, the same month as percentage to the February value. This chart has been prepared on the basis of Turkey Ready-Mix Concrete Association data. The values in the chart prepared as 100% for the period before pandemic, namely February, refer to the same month of the previous year. For the months of March and April, the chart, which is expected to be upward, moved downwards due to the pandemic. It can even be said that the values in these months are negative. The index, which reached its maximum value in June, still continues to decline. However, it is above last year's values. From this slide on, we are going to be talking about the indexes for materials used in building industry in Turkey. Turkey Building Materials Manufacturers Association data have been used for these slides and figures. What are those indexes? We can classify those indexes in two main groups. The first is primary index, which is called combined index. This index shows the combination of activity, trust, and expectations measured in the construction materials industry. Secondary indexes are indexes such Building Materials Activity Index, Building Materials Trust Index, Building Materials Expectations Index. To explain secondary indexes, Building Materials Activity Index is the index that reveals the level of activities carried out in the construction materials industry. Building Materials Trust Index is the index that reveals the confidence level of companies operating the construction materials industry towards the economy and the sector. Building Materials Expectations Index, the level of expectations regarding the level of activities in the construction materials industry in next 3 months. When we take a look at the activity index, a decrease is observed from February until April. The slow value continued in May. There was a regular increase until October. This increase still continues. When we get to domestic market sales values, since they are parallel activities, the domestic market sales follows the activity index as a trend. Although activity and domestic sales indexes have continued to rise since May, the slope of the rise of the trust index is lower than the others. However, it has started to decline again since September. Index of expectations also moves in the line with the trust index. The upward slope is lower after May. However, it started to decline again after September. Between the June-September, it can even be said that the value of this index is constant. Investment expectations index continues to decline after the minimum value of some value in April with a low slope until October. The decrease in people's expectations from the future and professional life has an impact on this decline. When we look at the combined index, it is seen that very low value in April and May continues to increase regularly. When we come to October, it is understood that we are very close to the values in February. For concluding remarks and post-COVID-19 foresight, we can easily say that Turkey construction materials industry negatively affected from the pandemic. With the decrease in the number of COVID cases, with the summer season, a recovery was seen in the building materials industry. The recovery that came with the summer season started to be lost again with the increasing number of cases and the seasonal effects with winter. For post-COVID, construction professionals await a recovery. However, the transformation of the construction industry has started to be discussed, reducing the amount of production in the construction site, transition to modular buildings using prefabricated products as much as possible on the construction site are among the discussed topics. I would like to thank to everybody for listening to me, and thank the organizing committee for inviting me to this conference.
Hello everybody, it's a Hello everybody, it's a great pleasure for me to be here. Hello everybody, it's a great pleasure for me to be here today talking to you how Brazilian construction industry is planning to recover post-COVID-19. I'm Professor Arthur Medeiros from South Brazil, and me and a colleague, Professor Lidiane, and engineer Luciana Rodriguez, we made an investigation here the past weeks to tell you the story how Brazilian is dealing with the COVID-19 and trying to get better from this. So we made an interview with different construction players with more than 75 industries and companies. How does the pandemic impact their companies and how they are planning to recover post-COVID? We started with some hypotheses that Brazilian currency devaluation was making prices increase and increase some exportation, and there is a lack of raw materials before September 2020. We will see about it. And the role of the government, because they give personal emergency aid and they help a few companies to pay their employees. So this is the geography of where we make our interviews. Because we are located here in South Brazil, in state of Paraná, most of the companies we talked was here in South Brazil. But we have a great number of companies here that could give us an idea how is the COVID impacting the construction industry. So most of them are cities in state capital. A few of them are small cities, smaller than 200,000 inhabitants, and the big cities are non-state capitals with more than 200,000 inhabitants. So the industry information, the primary industry sector is those who extract and production of raw materials. The secondary is manufacturing. And the tertiary are those who provide services or attend consumers, are markets of materials construction, or those companies that works in the field, construction, building, houses, industries. So check the numbers of the employees of the different companies we talk. Most of them are small companies, less than 20 employees, but a few of them are more than 100 employees, as you can see. So what happened to the billing, to the profit between April and November? So 90% of them said that it increased more than 50%. A quarter part increased less than 50%. Another quarter part said it continued the same as it was before. And just 22% said that it reduces less than 50%. And just 80% said reduced more than 50%. So check this out. 70% of the companies said that they have the same or better conditions. Why this happened? This is the story I'm telling you today. So those who increased profit said a few of those is due to the Brazilian currency devaluation because they export few materials. 11% of them because they were helped by government incentives. 27% of them created innovation implemented during the pandemic. So they had a problem, they faced a problem innovating. And most of them said they increased profit due to the increase of the demand for materials and services because people are searching for housing and there are higher value contracts. Why there are high value contracts? We will see. So those companies said that they decrease profit. A small part of them is due to the Brazilian currency devaluation because they are importing expensive materials. 7% of them is lack of government incentives. 9% of them is lack of manpower because they have to dismiss a few people or for health reasons these people are not working. 18% of them is due to the supplier delays or lack of raw materials. Why? Because there is an increase in consumption that we will see in a few. 20% of them said that demand reduction of materials or services, and most of them said that they have contracts canceled or postponed. So these are the reasons why a few companies had decreased their billing. About the lack of raw materials in the past 3 months, what happened? Well, it's delaying company activities and raise prices that impact the companies and the industries. But why? Because the stocks ran out. So this causes the delay. Besides, they have to renegotiate deadlines and they are searching for new materials. So those companies that are working with recycling materials, they are getting more money this year, even with the pandemic. Well, if raw materials are missing, what are the reasons for that? Part of this is because the Brazilian currency devaluation, a few companies that works with steel or with aluminium or other polymers or other products, they are exporting more. It's more profitable for them to send these materials for China or United States than to sell it to Brazilian commerce. Well, a third part of them said that the primary sector industries reduced staff. This is a story I'll tell you at the end. 80% of them because of lack of government incentives. Almost 20% of them because the consumption increase, and what we just said, because of the stock run out, is one of the reasons that raw materials are missing. So, in parallel, the economics in Brazil have cheaper loans, so we are making more construction. So, the construction demand increased. So, we are constructing more, but we have less raw material. So, this calculation will never fit. But okay, what to do to overcome the crisis generated by the pandemic? If there are people earning more money, they have to make a solution. A few of them are cheering for government incentives. 15% of them are investing in training or in tools or equipment. A quarter part is waiting for the vaccine. But check this out. Almost 30% are opening new work fronts, new fields, discovering new jobs. So check this out. Like 2/3 part of them are investing, discovering, trying to be creative to find a solution, not waiting for the government. But what could the government do? A few companies said that they don't depend on the government, they work by themselves. 20% of them hope for valuing the Brazilian currency, so this equilibrium of selling raw materials outside or inside could be better. 24% of them hope for low interest in loans, so getting easier money from the government to support construction. And a big part of them wait for tax breaks because Brazilian government put a lot of taxes in civil construction. So just remembering that most of the companies that we interview, they are being creative, they are investing, they are trying to get better besides the government. The main remarks is that Brazilian government in March 20, when the pandemic reached Brazil, they consider civil construction an essential service. So what happened? Most of people went home for 2 weeks or 3 weeks, but so the household reforms start to grow. Besides, there are more demand for housing, infrastructure, and I didn't write in here, but there are more demand for storage. Now we are buying, not in the shops, not in the markets, we are buying from our phones, we are buying from our television, we are buying from our computer. So we don't need to go to the stores as much as we used to do. So there is a great increase in storage industries. This is the nice part. In the middle, there are some adjustment in the routine. The lunch have to make shifts to not make agglomeration of people during lunchtime, temperature measure, removal of some employees that were suspect of COVID or get infected by COVID and they had to stay at home for a few weeks. The bad part is the dismissal of employees and the decreased demand in the commercial industry. And in the middle, we can say that the Brazilian currency devaluation helped some companies that worked with exportation, but didn't help companies that imported raw materials. So check these numbers. At the beginning of the year, we have 6.4 million people working in Brazil in civil construction. It's not a high number compared for you in India, but just to make a comparison with what happened the next months. So from April to June, when the pandemic reached Brazil, we lose 1 million people working for construction. And now we are getting better. We have recovered 0.4 million people working for construction. It's not the best. We are working little by little, but the main problem is the raw industries. They stopped their services for 1, 2, or 3 weeks in March and April. When they restarted, they didn't restart it in full potential. They were working in half of capacity. because they don't have all the employees, or they started to sell their stocks, that now that the stocks are run out, they have to produce the most of what their factories could do, but they are not attending all the demand. So there is a delay, there's an increase in prices. So we have a nice part of the pandemic that increased some types of construction, but we have less people working there. Less people working, the production is not the same, but there is a demand for construction. So this is how Brazilian is dealing with this, mainly because the Brazilian government consider civil construction an essential service. So I'm not sure I will be able to be online with you to discuss the next week because of the time zone. There is my contacts. You can talk to me whenever you want. I can send you this presentation. I can send you the Google Forms we distribute for those companies, so you can get more information about how we are dealing with civil construction. I wish you the best. See you soon. Bye bye. Hello, everybody. It's a great pleasure for me
Good morning, good afternoon, good evening to all the participants from the different parts of the world. It's indeed a pleasure to be presenting for this conference, which talks about enabling of construction or reviving construction industry in the post-COVID 2020 world. So now the topic that I would be talking about is sustainable construction materials and methods for infrastructure and housing solutions. And I'll be presenting a uniquely Indian perspective on COVID, its impact, and post-COVID solutions for post-COVID recovery. So now, what are the challenges that construction faced during COVID lockdown? One of our biggest issues with the COVID-related lockdown was the construction sites were essentially closed off. The labor was essentially forced to migrate. We depend on a lot of migratory labor which come and work on our construction sites. And most labor then were forced to return to their home places, hometowns, home cities. And therefore, the construction sites essentially went barren. There was absolutely nobody to support construction there. So now that was the one part of the equation where there was mass movement of people that in itself created a lot of logistic issues in terms of moving people around. But most importantly, the construction activity ground to a halt. Now, I'm just showing you some photographs of construction, which was abandoned. Literally, it was abandoned halfway, and even construction to the point where shoring was put in place, but concreting was not done. So this is the state in which essentially construction was abandoned with the start of the lockdown. Now, in addition to that, there was a severe disruption of the supply chains. So when you talk about the production, whether it is production of cement, aggregate, the local supply chains were completely disrupted because transportation was affected, and so the local supply chains got disrupted. That created issues like local material shortages, and unused material lying on the production site. So there was basically material which was lying unused on the on the construction site, and there was also it was not being available or made available to the production of cement and other places where it was required. The third most important problem faced by the construction industry was liquidity. Essentially, money disappeared from the market, and construction industry in India tends to be more driven by cash. It's a more cash-driven economy, and that was severely impacted by the lockdown. Now, it was basically a scenario that played out over a period of 6 months, where starting from lockdown, when the migrant labor was forced to leave the construction sites, the construction stopped, the material supply chains were disrupted, so the material could not reach the construction sites, it could not even reach the cement production units, so cement production and other ancillary support units also came to a stop. But basically that from this lockdown, I think there is a chance for us to re-strategize construction. And what I see is opportunities for us to look at construction and probably identifying issues that will help us develop solutions. So the need of the hour is for us to pause and rethink some of these strategies, the way we have been doing construction over the ages. And of course, at this point of time, I'm restricting myself to an India-specific scenario. Now, in India, in specific, we have construction is a large employer in India. So it does employ a large number of people. And the employment base is primarily delegated to low and semi-skilled labor. So this is a mass employer of people with limited skill set. And it is relatively a low technology, or there is relatively low technology adoption in construction. So these are things that one has to keep in mind. So we cannot think of knee-jerk reactions when you're talking about solutions and opportunities. In terms of adopting mechanized construction, or in terms of going scaling up to where we reduce the labor, because it is, after all, an industry that does feed a lot of people. And while we're thinking of solutions with these constraints that we have, we also have to balance our needs, because India is going through a very rapid expansion, and there is a very great demand for housing. There's a large demand for infrastructure. In the next 10 years, we'll be making investments to the tune of $2 trillion in our housing and infrastructure market. So that has to be developed. We need solutions which are humane so that we can actually keep our employment base still large, but look for solutions that basically address the issues that have come up related to this lockdown. So some of the solutions that I would like to throw out there, since we're talking about post-COVID recovery, is to talk about local utilization of material. We have a lot of material, and now with the advanced production that we do, we rely a lot on supply chains, and oftentimes material is sourced from different places, and the production of something like cement takes place in a different location. So we need to look at materials being used for products, and probably look at more local utilization of materials, so that we can get away from or have a parallel system which can be sustained by local development, which is not does not depend upon the supply chains which bring in material from large distances. We need to look at things of employing labor locally. So this whole problem of labor migration would mean that if we can create employment in construction, of course, locally. Now, of course, the issue there is that typically the labor migrates from a rural setting to an urban setting, because most of the construction is in the urban setting. So now, how can we employ labor locally? We need to look at production which supports construction. That's what we need to look at. So look at more prefabricated products which are made with local materials, which can be done in a rural setting, so that these then serve to support the construction in the urban centers. We of course have to look at efficient construction. So we have to look at reduction in labor intensive processes at the site. So these have to be supported by back-end production, which can then be done locally in the rural setting. So this is the kind of model that we probably have to think about, where we keep our employment base still large in construction, but then we have a lean construction site where at the construction itself we are looking at more prefabrication, more precast materials that are being used, which also speeds up the construction, makes the entire construction process more efficient. And therefore, we are looking at a faster turnaround of constructed products. So what I'm going to do is now present on some of the opportunities and solutions, three specific things that we have worked on, which probably look at providing opportunities and solutions. The first one is with the use of excess fly ash locally in precast and prefabricated products to support construction infrastructure. And I'll present this in a little more detail in the next few slides. India has basically produces more fly ash than it can consume, and most of it is not being done in urban centers. So therefore, we have this construction material which can be utilized locally. So it can be utilized locally to produce precast elements and structural elements. So now, rather than move the fly ash across the country, use it locally to produce these precast elements right next to where it's being produced, which happens to be in most of the times in rural settings. And then those can then be used to support the construction happening in the urban centers. Then we are looking at local production of units using local materials, which basically are a value add and provide employment. So this is basically using local materials. And in specific, I'll talk about stone panel technology, which uses excess stones, which are produced locally in one specific geographic location in the southern part of India, to produce precast floor panels. And these precast floor panels can be used, can be deployed very rapidly for providing flooring in urban construction, in precast construction. Then the last thing I'll touch upon briefly is rapid housing solutions, because we do have a great demand for housing. And I'll just quickly present on the sandwich core technology, which can also be looked at for providing solutions for housing. Now, a quick background: cement, past, present, and future. India is right now the second largest producer of cement in the world, but our projected production, basically in 2050, if we are to go continue at the same trend, will make us the #1 producer of cement in the world. Now, some of the challenges we are currently facing with cement production are that our current limestone reserves are expected to last only 30 to 40 years. The energy requirement for cement is also quite large, and that is also one of those issues that has to be addressed. And the carbon footprint, of course, remains to be an issue. Now, with this background, if you look at the other scenario, where we look at coal consumption and fly ash generation. Now, the countries in the red that you see in this figure here, these countries in the dark red are basically the largest producers of fly ash in the world, the three largest producers. India is actually right now the second largest producer of fly ash in the world. Our coal consumption in India currently is about 536 million tons per year, and it's only expected to rise because we are commissioning more coal burning thermal power plants. Our current dependence on coal burning for production of electricity is to the tune of 70 to 75%. So that is bulk of our power production. But going forward now, with an increase in the power demand, we are going to rely, at least in the immediate next future, in the next decade, we are going to rely more heavily on coal burning power plants. So if you look at this graph here on the bottom right, you see the amount of fly ash that is being generated and the fly ash that will be generated in the future. Now, the green bars in this graph show how much fly ash is being utilized. And if you look at it, it is a small fraction. This includes all the fly ash that has been incorporated in construction and all the other uses that are there. So currently, a lot of fly ash is sitting in the form of fly ash dikes, fly ash ponds. So basically, this is fly ash that needs to be utilized. And like I mentioned before, this is sitting a lot of times in the rural centers of India. So now we need to look at solutions to fly ash, and that would help us kill two birds in one shot. That is, can we beneficially utilize this fly ash and do basically produce elements which can be used to support construction, rapid construction in the urban center. So that would basically allow us to utilize this fly ash beneficially, produce products in the rural setting, and those could be then used to support the construction in the urban centers. So if you now look at the fly ash in India, there is, of course, if I just go to the previous slide, this map of India here shows the different thermal power plants in India, and there is a almost equal geographic spread of these coal burning power plants across India. But what we did is initially to come up with solutions, we first wanted to understand this fly ash. So fly ash was collected from different power plants across the country, and it was analyzed. And what we found is that most of the fly ash, if you look at just the oxide compositions, there is a very small difference in the oxide compositions of this fly ash. But when we started using this fly ash in concrete, we found that the results were night and day. There was a big difference in the final strengths, the final properties that was achieved with these fly ashes. So to understand that, we had to do a higher level of characterization. The one unique thing about fly ash that's produced in India, or I should say the fly ash that is predominantly produced in India, most of it has very low lime content. It's very, very low. So most of it is class F fly ash. Now, what we did is we basically, from characterization, established the reactive silica and the reactive alumina in the fly ash. These are the two reactive elements in fly ash, which are most beneficial for use in cementitious systems or in alternate binders that are being produced nowadays. Now, if you look at the same 10 fly ashes, the blue line represents, or the blue bars represent the total oxide contents of the fly ash, and the green bars represent the reactive oxides. So if you see here, now the differences start showing up. While the blue bars are almost comparable for all fly ashes, in the green bars, there are a lot of differences in the reactive oxide content. First thing to note here, the reactive content is much smaller than the total oxide content. That means only a small portion of the total silica and the total alumina in the fly ash is available in a reactive form. And it can be as small as 13% of the total silica being reactive, and about 7 or 8% of the alumina being in the reactive form. So this is a lesson for us, where we realize that the fly ash, whether it is the production process, the boilers that are used, the temperature of processing, or the collection, there is fundamentally the fly ash we're using is of a very low reactive, has very low reactive content. So our next step was actually through this characterization, we established that from XRD based analysis, we found that most of the fly ash is basically the oxides, the silica and the alumina are locked in crystalline material. So if you look at this XRD, the graph that I'm showing here, a lot of the fly ash is locked in crystalline content of quartz and malite. Quartz is sand, which is very unreactive. So a large percentage of the fly ash is locked up in this unreactive forms. Basically, the reactive form is this glassy phase, which is shown in this orange line. So, and that is what we are interested in, but that content is low. So our next step was to look at the possibility of producing geopolymers with this fly ash. And basically for geopolymer production from a given fly ash, it is the reactive silica and the reactive alumina that are important. You take the fly ash, it is activated in an alkaline solution which contains dissolved silica. And basically when you subject it to a elevated temperature curing, what you end up with is a geopolymer, which is basically um, densely cross-linked network of silica and alumina, as I've shown here. Now, and this geopolymer, if it is produced from this alkali activation of fly ash, particularly the low calcium fly ash, tends to have a much higher strength than cement. It is much more durable, and it has very good fire resistance. So basically, it is an ideal material that can be used for construction. The only problem there is, of course, the temperature. So now, what we did is understanding the chemistry of the fly ash. We basically developed a process where, using this low reactive fly ash, which is predominantly available in India, by optimizing the chemistry, by playing around, by determining the reactive oxide contents, by optimizing how much bind activators need to go in there, and activators are primarily provided in the form of sodium silicate and sodium hydroxide. Understanding the role of these in the entire reaction chemistry, we've been able to produce geopolymers which consistently give us strengths of about 80 megapascal. And basically, we've also reduced the temperature demand for curing down to 40 degrees Celsius. And that is basically the temperature that is common in summers in India. So basically 6 months of the year, the high temperature in most of India exceeds 40 degrees. So basically, we're able to achieve a binder that gives us 80 megapascal strength using fly ash, which is a waste material. And this entire process has been developed by understanding the chemistry of the process. Now, from there, now we are able to come to a point where we are able to collect fly ash from different thermal power plants and optimize the activator for this, and be able to produce cements which give us consistent strength and consistent properties. And these is done following the characterization of the fly ash in the that is obtained from these thermal power plants. And this cement would basically produce a geopolymer, which gives us consistently high strength and high durability. So while we are looking for support, so now this is fly ash that's being produced in across the country, and mostly in rural settings. So we are now looking to see if this material could be used to support infrastructure development. So now steam curing can easily be adopted, and it is being done for producing a lot of construction related products. So if you look at steam curing that is conventionally followed, we basically raise the temperature to about 85 degrees Celsius, hold it there for some time, 6, 8 to 10 hours, and then we cool down the product. And this is the ideal temperature for geopolymerization to happen. We can actually accelerate the geopolymerization and deliver the strength much quicker, as I had shown before. So because these geopolymers that are produced from fly ash have a very high acid resistance, they are ideal candidate for making these precast pipes, which can be used for sewage and even for transporting water in the urban setting. So now here is an idea of a precast product that can be made in close to the thermal power plant and can be used to supply the demand in the urban centers, or the requirement for infrastructure in urban centers. The other thing is also the tunnel liners. These are tunnel liners that are used to stabilize tunnels, and these tunnel liners again can be quickly made out of these geopolymers and can be used to support the infrastructure development. Now, another product that we're working on very closely with this fly ash is with developing cellular masonry blocks, which basically provide enhanced building envelope performance. Now, India is a hot tropical country, and for us, it is important that we keep the heat out of our houses. Now, most of the heat gains into our house happens through the walls, and basically, whatever we can do to increase to reduce the heat gain into the house would essentially involve trying to develop walls which have low thermal conductivity. And basically, what we are interested in is developing these bricks, and these bricks are used as infills inside a reinforced concrete frame. And basically, they are the outer envelope. This is the outer envelope of the building, which is exposed to the outer environment. Now, these bricks are currently made of what is known as autoclaved aerated cement blocks, which have a low thermal conductivity, but they're made of cement. Now, what we are, and I'm showing you the process of the autoclaved aerated concrete blocks, where cement is basically a cement-based matrix or air is entrained in the cement-based matrix in the form of tiny bubbles, and the entire cement block is autoclaved, and what comes out of it is the autoclaved aerated cement block. This AAC block is then used in making masonry, which basically makes the infills between the reinforced concrete frames. Now, what we are proposing is to use the same process of autoclaving, the process of autoclaving that is used for cement-based blocks, instead use geopolymer-based blocks. So we can use this fly ash, which is alkali activated, with the optimized binders, which delivers this high strength. We entrain it with this porosity in the form of tiny bubbles. We autoclave them, and we can produce masonry blocks. And we are even thinking of making these wall panels. Now, these are wall panels which basically can be used as infills, and this is technology that can readily be developed close to the production of the fly ash itself. And this is again would be used in employing a lot of labor close to where the production of these panels takes place, and can be used to supply the demand in these cities for infills in construction. So these are a few of those things we are planning with the fly ash, which basically decentralizes the production, takes the production closer to the where the fly ash is being produced, and generates employment in construction related activity close to where the fly ash is being generated. Now, the other two things I wanted to talk about is, one is coming up with use of local materials for construction. Here is a specific example of what we worked on with local materials. One of the common things that's found across India are stones. Stones are abundant in India, and stones from specific regions or areas like Tandur, Kota, Makarana, these are world famous for their quality, and have been used traditionally for different forms of construction. Now, Tandur is one particular stone which comes from a region in the peninsular part of India, where basically the stone is from a slate which is of a layered formation. It has traditionally been used in construction, and what you see here is a traditionally constructed house using this Tandur stone, and it's used as a roofing material and even for the construction of walls. Now, during the production of these tiles, which are used in construction as floorings, floor tiles, or sometimes even wall tiles, a lot of waste is produced. So we basically were looking at developing solutions to use up this waste, and also to deliver a precast construction product, which could be then used to support construction. So we came up with this innovative, eco-friendly precast natural stone composite floor system. Here we have the natural stone slab, which basically is cast in a ferrocement bed and supported on joists. So this is a precast unit that is made with these floors, with the stone slabs. And the stone slabs, initially we were using a square cut or rectangle cut stone slabs, but now we've moved to using irregular shaped stone slabs, which are essentially waste from the stone industry, and to develop these precast floor joists. And these precast floor joists can then be used directly to assemble the flooring system at a very rapid pace in a total precast manner. And this is the assembled floor where all the slabs have been assembled. They're simply leveled, and you have a very quick flooring system that is developed by using these stone panels, which are produced in one of these rural pockets in India. So the whole point is to set up this precasting unit, which would produce these precasting wall panels and even precasting slab panels, which could then be used in urban centers to meet the requirement of flooring and for use as wall panels. Now, one of the advantages of these the floor panels as they're used is that because the top surface is a stone and it can be polished, one does not need to provide any finish to it. So the natural surface of the stone can be used as the finished surface. So thereby we also save material in the whole process. So the stone is acting as a structural material in this precast panel, and it also provides the finished surface after construction. So again, the construction, the production of these precast panels is being done in this rural part in Tandur, and the finished floor panels are shipped to the city. And one example here is where they were shipped to Hyderabad, which is a city, and used for construction in Hyderabad. So we are able to generate employment in the rural sector where the labor had migrated to, and at the same time keep the construction site in the urban center clean by adopting precast technology. So it's a leaner construction site in the urban setting. So just to show you some photographs of this integrated precast beam column system with the slab wall with the stone panel system that was used as floors. Now, the final thing I want to talk about is the 3D reinforced system for walls and slabs. Now, this is the wall panel system and even a slab system that has been developed, where basically we have 3D integrated wire mesh, has this, which has a core which is made of expanded polystyrene (EPS). Now, what is done is that layers of concrete are basically cast on both sides of this EPS core, and we have wire mesh reinforcement on both sides, which serves as the reinforcement to this concrete layers on both sides. So this these integrated 3D wire mesh reinforcement of the EPS core is basically then assembled in the form of walls or slabs, and simply by concreting the two layers of concrete, the entire structure can be built. Now, this is basically being used a lot for prefabricated low-cost housing. The sandwich core technology has the advantage that because it has a EPS core, which has a very low thermal conductivity, it provides a very high thermal comfort. Now, of course, the limitation currently is that it's limited to small spans and simple structures. So it is ideally suited, and of course, it's ideally suited for modular construction. And it is a great solution for providing potential solution to housing problem in India, where we have a great demand for housing, both in the urban and in the rural sectors in India. So what is the advantage of this particular 3D reinforced EPS sandwich core technology? First is we can use local masons. So this labor that has migrated from the cities to the rural areas can be employed to make these panels. And these panels could also be used as precast panels for use in construction. So the production of the panel itself takes place wherever the labor is or wherever they have moved to. It, of course, provides very rapid construction. It has high thermal comfort. And overall, it's a lightweight construction. So there's saving in materials. So these are the three things that I wanted to present with India specific, which are India specific potential solutions for this post COVID disruption that was created. And the majority disruption had to do with the migration of labor, where the labor moved from urban centers to back to rural areas, and basically trying to clean up the construction space so that we make the construction space in the urban settings which are more efficient, with leaner construction, with lesser labor, but at the same time keep the employment in the rural sector by providing opportunities there in the form of support, where basically support structures can be made there, shipped to the rural center, from the rural to the urban centers, and used for construction there. So with that, I'd like to thank you for your attention, and I hope everyone is keeping safe, and hope sometime soon we all get to see each other once this pandemic is lifted. So thank you once again, and I'd like to thank the organizers for giving me an opportunity for presenting my opinion on this topic. So thank you.
Hello, name is Satish Desai. I wish to share with the experts on the committee my views on construction activities during the COVID-19 pandemic and potential for the pandemic revival. COVID-19 has detrimental influence on construction industry in many parts of the world, which depends on their national regulations and construction practices. In the United Kingdom, gross domestic product GDP was 30 million out of construction. This was in the beginning of 2020. It reduced to 19 million, apparently due to the onset of COVID-19 later in the year. Changes to governmental legislation can have an undesirable effect on construction. For example, there is a lockdown now imposed from 6 November in place of the variable restrictions that prevailed depending on the various degree of severity of COVID-19 infections in the country. Construction projects need outdoor workers as opposed to the working at home facilities in other fields. Moreover, forward planning is of paramount importance, together with programming various activities that require execution within time limits. This is in the interest of avoiding delay and prolonging the critical path. Changes in legislation, if they are unexpected, can present serious problems for effective forward planning. Situation during the pandemic. COVID-19 has primarily slowed down the major construction projects, although not totally stopped them. The main reason can be cited as delay and disruption, including that caused by delay in supply chains. A few projects have been provisionally suspended, usually with the intention to resume work at a later date. The main reasons for continuing these projects are construction and infrastructure projects are important, very important for countries' business and other industries. For defense against spread of COVID-19, safety procedures can be implemented. With some discipline, they are there. For example, social distancing, 2 meters or 1 meter or whatever, self-isolation of a worker with high temperature or new persistent cough, site access limited to essential persons only, no visitors, hand washing, toilet facilities, and safe provision for travel to site. Provision for cleaning, eating arrangements, changing facilities, showers, drying rooms. Health and safety risks associated with the COVID-19 vary from site to site. For example, people working outside, especially in rural areas, can comply with precautions better than those in congested urban surroundings. For example, social distancing, wearing masks is easier in outdoor open spaces. The contractors can seek relief from its debt obligation. They can have financial agreement to mitigate the income that is reduced. The causes can be presented as potential project delays, cost overruns and claims, difficulties in obtaining materials and components, cost for public health measures for containing COVID-19. Everything costs money, of course, social distancing, extra sanitary provisions, etc. Post-pandemic revival is possible, especially in the UK. Construction industry is expected to recover after the current lockdown. provided that during the lockdown, the contractors and workers keep taking precautions against the spread of COVID-19, and that the financing situation is handled with care. Both the debtors and the loan providers are understanding. Everything is done to continue major projects. Recovery will depend on the prevalent restrictions that remain post-lockdown, clarity of regulations, more important, consistency of regulations. Also, some flexibility is expected in review of the special nature of construction practice. If we are very optimistic, we can expect that the program duration can be delayed by some 10% only. Not very significant, you may say, provided that there is no need for social distancing measure. Social distancing could be worse for inner city projects such as there are in the UK. Some rural projects like high-speed 2 can cope with it. Important workers should observe self-isolation if any one of them displays symptoms of COVID-19. Potential problems that will need careful planning, understanding on part of the government and the industry. First, workforce availability. Contractors will find it difficult to recoup the workforce when the shutdown is over. The only way could be to slowly increase the workforce during 6 to 8 weeks. It is questionable, however, whether the operative numbers will return to previous levels soon enough. Quick recouping may be tempting, but it may be risky if there comes another lockdown and the contractors could find themselves overstaffed once more. Material availability. Many contractors follow a just-in-time delivery policy. However, many construction sites may start demobilizing more or less at the same time. This may potentially create a material shortage of materials. Moreover, manufacturers will have to adhere to the same government guidance, and they would not be able to pick up where they left off before lockdown. Flexibility on part of the government could help. Social distancing should be relaxed, say 1 meter in place of 2 meters. It might reduce the impact on output of the site. Manual work requiring a minimum of 2 people. They have to work close to each other. It should be allowed, therefore, provided that all personal protection measures are in place, mask, etc. Operatives should be allowed to travel to work on sites that are outside their local areas. Longer travel distances should be permissible where there are no facilities to house operatives close to the sites. Well, these are all hopeful thoughts. They may differ in different countries, but however, I'm sure that you will cope with the problem and get the construction industry back on its feet again. Thank you very much for your attention. Bye.
Hi everybody, thanks for joining and listening to me. First of all, I want to introduce myself. My name is... Hi everybody, thanks for joining and listening to me. First of all, I want to introduce myself. My name is Uğur Erşen Şenbil, and I am from Turkey. I'm a chemist and completed my master and PhD education based on cement and concrete chemistry and chemicals. I have worked in Fosroc Construction Chemicals for 8 years as a technical manager, And now I have been working in Akkim Kimya for 1 year, which is one of the largest chemical company in Turkey. And I am a R&D manager in this company and responsible from the construction chemical department. And in this presentation, I will represent Turkey Concrete Mortar Admixtures Association at the same time because I'm a member of technical committee of Concrete Mortar Admixtures Association. So first of all, I will tell you who are we, who is Concrete Mortar Admixtures Association, and after that I will tell our activities. Then I will mention something about the effects of pandemic to Turkish economy and our business. And after that, I will tell you concrete admixtures market in Turkey. Okay, who are we? CUBE, I will call our association as a CUBE. It's a Turkish pronunciation. And our association was established in Istanbul in 1998. And this association is a non-profit and non-governmental organization. So we are not gaining money from anything. We are bringing concrete and mortar admixture manufacturers together. And members of this association represent a really significant capacity in Turkey and European markets. I will tell you in upcoming slides also. So who are our members? Who can be our members? Concrete and mortar chemical admixture manufacturers, cement grinding aid manufacturers, and fiber manufacturers can be our members. So which federations we are a member of? First of all, Construction Products Producers Federation in Turkey. We are a member of this federation. And secondly, we are a member of EFCA, and EFCA is European Federation of Concrete Admixtures. And many of countries in Europe are also a member of EFCA. So what are our activities? CUBE represents Turkey in EFCA Technical and Environmental Committee. And there are two committees in EFCA, and these both committee really works very well in terms of the technical things and also environmental things. So we represent Turkey in these committees, and this association also provides EPD to its members. So what is EPD? EPD is Environmental Product Declaration form, and this means that we are measuring effects of our admixtures to environment. So we are making some calculations based on the formulations, our product formulations. So if a score of our calculation is under limit, we have a right to have this EPD document, and after that we can declare this document to our customers, which is really very important. So if you are a CUBE member, which means that you have a chance to get this EPD document. And the next one is standardization works. You know, SAN is responsible from making new standards and the revisions in current standards. So SAN is in contact with EFCA, and if there will be any revision in some standards, EFCA asks its members. So for Turkey, we are making all the tests for standardizations, and we are sending our results to EFCA, and via EFCA, we can reach SAN. So next one, technical trainings in universities. As I told you in previous slides, we are a member of Construction Product Producers Federation, and this federation organizes training seminars in universities. So we are going to universities and we are telling what is admixtures and how can we use them, how can we produce them, and which standards are important. So we are giving trainings to university students, which is important. And next one is sectoral seminars and conferences. And some of these seminars we are attending just as an attendee, but some of them we are organizing them. So we have always chance to make some articles or be giving presentations in these seminars. And the next one is admixtures quality management agreements. You know, we have members, and all these members are producing products, and we are making agreement with the Turkish Ready Mix Concrete Association, and they are taking randomly product from the sites from any of member, and the third party laboratory making all the tests, and they are measuring if the results are in spec range or not. So we are also making agreement with this management, and we always in contact with other national construction associations like Turkish Cement Manufacturer Association, Turkish Ready Mix Concrete Association, and the Aggregate Association. We are always in contact with them. And the technician training course is also an important subject for us. And in time, any of our members giving course to technicians in the sector, and they are inviting all technicians to their laboratory, and theoretically and practically they are giving a technical course. And the last one is technical articles and bulletin. Actually, we are writing and we are working on new articles, new subjects, and always we are advertising these articles in our website or in some seminars, sectoral seminars or any conferences, which is important for us. And if anybody just contact and asks anything to us about what is admixture and how can we use that, how can we produce that, which standards are important, what should we do, always we are telling and we are writing, and we are sending these documents to universities and any conferences. Chemical concrete admixture market in Turkey. According to the data of EFKA, Turkey has the largest concrete admixture market in Europe. When we look at the number, Turkey has 40% of total concrete admixture market in Europe, which is really very, very big and huge. CUP represents 85% of market in Turkey with its member companies. When we look at the last year's numbers, last year's data, 457,000 tons of concrete admixture were produced in 2019 in Turkey, which is really huge. And when we look at the cement and concrete volume, 57 million tons of cement were produced in 2019 in Turkey, and also 67 million cubic meter concrete were produced last year in Turkey. And these numbers are really huge when you consider a European market. And pandemic, you know, which is very important subject for all of the world. And when we look at the Purchasing Manager Index, you can see the lowest peak in April 2020, because we firstly faced pandemic issues in March. So that's why April was awful month, also May was awful. Because of that, we could see a sharp decrease in April. But after that, the sector was recovered really very fastly. And you can see the highest peak in July 2020. So which means that after a couple of months later, the sector was recovered. And here we can see gross domestic product. And there are 3 years here, 2018, 2019, and 2020, based on 4 quarters. And we again see the sharp decrease in second quarter of 2020, and it was about 10% decreased. And this was one of the highest decline in Turkish economy history, actually. So we can say, as all over the world, the pandemic affected Turkish economy really very badly. Okay, now I will tell you last 5 years data in terms of the concrete admixtures in Turkey. First of all, I will tell you chemical, concrete, and mortar admixtures production volume between 2015 and 2019. And you can see in 2015, 476,000 tons of concrete and mortar admixtures were produced. And when we come to the 2017, we can see 600,000 tons of admixtures, which is really great number. And this year was the highest production volume. And after that, it was started to decrease in 2018. And we can see in 2019 the lowest number, which is under also 2015. And this was because of actually the economical crisis in Turkey. So based on this graphic, we can say that 2017 has the highest production volume and 2019 has the lowest production volume. So volume decreasing was also started the first time in 2018. And next one, you know, maybe we are following EN standards for concrete admixtures, and the EN 934, yeah, 934 standard is very important for us, and we are following that standard. And according to that standard, there are different kinds of groups in concrete admixtures, and there are classifications. So one of the classification in that standard is water reducer and plasticizer, which is one of the important group. And when we look at this group, last 5 years, in 2015, Turkey produced 100,000 of admixtures, and until 2018, the number was increased in each year. And 2018 has the highest production volume with 190,000 tons. And after that year, it was decreased last year because of economy, as I told. So with this graph, we can say that need to water reducer plasticizer group was increased in recent years when we compare to the high range water reducer and super plasticizer group. And it will be in the next slide. Here we can see that this is also another group in EN standard, high range water reducer and super plasticizer group. And you can see it was much more than water reducer and plasticizer in terms of the production volume. And again, it was increasing in each year until 2017, and it was started with 300,000 tons until 370,000 tons in 2017. And after that, it was started to decrease last 2 years. And you can see there was a really sharp decrease when we compare with the water reducer and plasticizer group. So we can say that need to high range water reducer group was decreased in recent years compared to water reducer group. So last 2 years, need to water reducer group was increased actually. So next one is shotcrete admixtures. This is really, again, another important admixture group in the standard. And we can see a very good increase in terms of the production volume numbers. And it was started with 57,000 tons in 2015. And until 2018, it was became 80,000 tons, which is really very big. And after that, last year it was decreased from 80 to 72,000 tons. But when we compare with the plasticizer groups, we cannot say that this was decreased similar as the water reducer groups. This was decreased actually just a little bit when we compare with the previous groups. So again, we can say 2018 has the highest production volume for shotcrete admixtures. And with this group, we can say that the tunneling and the mining industry became an attractive position in Turkey because shotcrete admixtures are used mainly in tunneling and the mining industry. So this is a really very good and very attractive industry in Turkey. So the other groups, I'm calling that minor groups because the production amount is not very high actually. So that's why I'm giving you the data of these 5 groups together. And the first one is water retaining, then A-brain training, accelerators, retarders, and water resistant groups. And we can see not increase and not decrease between 2015 and 2017, but after 2017, this 5 group were started to increase, and 2018 has the highest production volume for all. And after that, 4 of them started to decrease. Just only air and training concrete admixtures was increased in 2019. Totally, we can say that need to these admixture groups were increased in recent years. And when we come to the conclusion, Turkey has the largest production volume in Europe, and within the last 5 years, the year of highest production amount was 2017, and lowest production amount was 2019. But despite this lowest production amount, Turkey was still has the largest production volume in Europe, despite this position. And high range water reducer super plasticizer admixture group was produced always much more than the water reducer admixture group in each year. So the gap was started to decrease actually when we compare last 2 years, but again, high range water reducers were always higher than the water reducer groups. And until 2019, production volume of shotcrete admixtures was increased each year, and in 2019 it was decreased again, but as I told, the decrease amount is not the same as the other groups. So again, this is one of the good admixture group. So while the other chemical concrete admixtures were increasing in small amounts between 2015 and 2017, the increased acceleration in 2018 reached its peak. This is really very important, and it was the year of highest production in terms of quantity. So lastly, I can say that after all this data, Turkey is in an advanced position of know-how, production, and application technology in terms of chemical concrete admixtures. Thanks for joining, and thanks for listening to me. And these are the people of our members, Turkey Concrete and Mortar Admixtures Association. Thanks again.
My name is Mohammed Bashir. I'm a professor in structural engineering at the University of Leeds. It's a pleasure to be a participant and a speaker for the India Construction Week. And my talk is entitled Technology Enhanced.
Hi, everybody. Thanks for joining and listening to me. First of all, I want to introduce myself. My name is Uğur Erşan Şenbil, and I am from Turkey. I'm a chemist and completed my master and PhD education based on cement and concrete chemistry and chemicals. I have worked in Fosroc Construction Chemicals for 8 years as a technical manager, and now I have been working in Akkim Kimya for 1 year, which is one of the largest chemical company in Turkey.
My name is Mohammed Bashir. I'm a professor in structural engineering at the University of Leeds. It's a pleasure to be a participant and a speaker for the India Construction Week. And my talk is entitled Technology Enhanced Education, Training, Research, and Management for Post-COVID Revival of the Construction Industry. This talk is co-authored by Harshida Garg, Kai Yang, and Leon Black from University of Leeds, and Srijit Nankutan, Danny McPaulin, and Amy McCabe from Queen's University Belfast. The outline of my presentation is as follows. I would like to give first an intro into productivity challenges in the construction industry, then discuss some technological innovations that could help to improve the productivity, followed by a discussion on education and training, and finally to conclude with some recommendations. So first of all, the productivity challenges in the construction industry. As you can see from this graph, there is a productivity gap between construction sector and the rest of the industries. And McKinsey and Company in 2017 estimated that this could be of the order of 1.63 trillion US dollars. So you will see that in the next graph, the difference between the growth from 1995 to 2014 in the construction sector in blue and all of the sectors together. So naturally, the growth of the construction sector can be better. And what are the roots of the productivity problem? According to a Disperse, a company which is now focusing on improving productivity, it is systemic industry-wide productivity challenges which ties to the status quo, organizational productivity challenges that affect business units from headquarters to project level, and which limit construction businesses from achieving economies of scale. And finally, personal productivity challenges that bog down staff at an individual level, slowing down delivery and making the job less satisfying. What did COVID-19 do to the construction industry? Initially, there was the loss in construction activities due to the stoppage of all construction activities. And slowly, it was realized that there is the need to revive the construction industry because investing in infrastructure projects would help to re-engage the construction workforce and drive the economy forward. So currently, many countries are at a phase of investing in infrastructure projects to kickstart the economic growth. So the objectives of my presentation today are to demonstrate how construction productivity could be improved, particularly focusing on COVID-19 safe activities on site. To introduce a range of research and innovation in construction materials and technologies which could improve construction productivity, and to share some ideas in education and training to help improve the quality of workforce and thereby the quality of the infrastructure projects. So let me give you a summary of the building productivity through technological innovations. And first, the precasting and 3D printing. These are two examples from India where precast concreting is used to construct residential houses. The first example is from Uttar Pradesh and the second one is from Kerala. In both cases, the facilitating factors are the fact that we have high strength, high performance concrete now available. The admixture technologies would facilitate the construction of prefabs. Advances in fiber reinforced concrete and pre-stressed concrete would enable this. And there is improved understanding in structural connections to facilitate the connection of structural prefabricated units. And of course, there is the improvement in construction workforce that would be required for this type of work. So from a change from the cost of construction at the beginning to whole life cost and life cycle analysis, that also helped in going for precast concrete manufacturing. And if people are now aware of or concerned for the sustainability, that also is driving this. Another area is the flexible arch. It's a small. It is used for small to medium span bridges. It's an example from Northern Ireland. You can see from here the flat pack precast units are brought in, lifted, placed in to form the arch, and then tied together to get the bridge needed. It is patented and of course, promoted through a precast concrete industry in Northern Ireland called Macrete. It's successfully used for spans up to 18 meters, highly cost-effective and durable, and bridges can be instrumented to obtain performance in surveys. Now, the second technology is the 3D printing. As you can see from here, from 1997 up to now, there is an exponential growth in the use of 3D printing and additive manufacturing. It is becoming an attractive concrete technology. And the reasons are, there is no need to use formwork, less labor used, there is a saving in construction time, there is better working environment, less construction waste, reduces the risk in construction, and it reduces the overall cost. All of them would facilitate the 3D printing to become a technology for the near future. You can see the world's largest 3D printer building in Dubai in 2019. It's a two-storied 3D printer building constructed by a US-based company. It used local materials and it is efficient in insulation, hence reduces the energy consumption. What are the facilitating factors for going for this 3D printing technology? Of course, one is the advances in material technologies. Second one is the advances made in building information models, construction robotics, artificial intelligence, and construction informatics. So just wanted to have a brief chat about construction robotics, artificial intelligence, and construction informatics then. Construction robotics would become the new normal because with advances in technology, robotic technologies are widely used to achieve greater efficiency in the performance of construction tasks and also to improve working conditions in the construction phase. The market drivers are high level of construction growth expansion activities, unsafe environment, which would result in injuries to labor, and like what we have faced recently, any pandemic could bring in uncertainties. And it can be used for different construction activities such as structural demolition, bricklaying, assembling prefabricated components, welding, construction of roads, unlocking of different advanced design possibilities, carrying out aerial surveys of structures. For different applications, construction robotics could be used. Here is actually another example where the image-based system is used for advancing the technology. And this is called a virtual sieve. Instead of using a physical sieve, image-based system can be used for characterization of sand, gravel, and concrete. So you get the distribution of the material, and from that, we will be able to decide what's the pore structure that is likely to result, how much of material needs to be used. So we will get a better understanding of the raw materials in the conveyor belt in plants. We can reduce the energy demand. We can increase the packing density for the concrete. We can reduce the consumption of the cement, and overall quality can be improved. Another example of the use of image-based system is the virtual reality assessment of roads. This is another example from Northern Ireland. The Amy roads, Northern Ireland used laser scanning technology for scanning the bridges. You can see the bridge on the left-hand side and the scan image on the right-hand side. So Crossrail in the UK used the drones to inspect structures. This is the example shown here, a building damaged by fire. For site inspections, health and safety inspections, crane, tower and scaffolding inspections, site planning, getting 360-degree panorama of the structure. For all these reasons, we can use drones and image-based technology. And talking about image-based technology, here is another case. It's a cliff edge in Northern Ireland. This work was done by Amy McCabe from Queen's University. And you can see on the left-hand side, it's 60-meter high. The boulder field is inaccessible for doing any surveying. So you can use drones to survey and capture the image, and photogrammetric models can be built from which you can get really, really accurate measurement of the boulder on the slope. So a combination of artificial intelligence and construction informatics can be used in different projects. And this is a snapshot taken from a publication which you can get it from BIM+co.uk. So digital twins used, and this particular case is actually the Mayfield project owned by Mace, and a particular AI technology pioneered by Disperse is actually being used for the COVID-19 safety, managing the building for COVID-19 safety challenges. So you can see different systems can be used for in combinations for different applications. A brief mention about structural health monitoring and whole life management then. The rationale for structural health monitoring can be seen from this slide. The blue line here is where the construction at the inception, the initial stage itself is of top quality, and slowly the performance deteriorate, but it will never go below the minimum acceptable level. So such a system possibly is used for nuclear containment structures. However, the cost associated with this could be really, really huge. If on the other hand, if you try to save the cost and go compromise the quality at the beginning, you can get actually complete failure, which means that there has to be complete reinvestment in the structure, which would cause huge amount of money to the industry. However, what is normally done is certain level of initial quality is ensured. There will be deterioration with time. At a particular stage, when it reaches the minimum acceptable level, there will be an intervention strategy to restore the structure, and again it will be allowed to deteriorate and then again restored. So this is what is normally done. And the cost associated with this possibly is going to be less than the cost associated with the case one. And how do we get this information? How far it has deteriorated? That information can come from either periodic inspection or putting structural health monitoring systems in place. And that means for early age detection of problem as well as timely intervention and management of infrastructure, structural health monitoring systems can be used. Two examples I want to share with you. This is the Hanju Bay Bridge in China. It's work done in partnership with the Zhejiang University in China. It's a bridge which is 35.6 kilometers long in very aggressive conditions. For example, the wave height is 9 meters, wind speed more than 30 miles per hour. So we have this service center here, somewhere in the middle of the bridge, and that is where we located our monitoring station. And this is another example. It's a Donark test site in Scotland, where we installed sensors in test pillars and measured the performance of that. Different types of sensors are available, both fiber optics as well as electrical resistance sensors. The fiber optic sensors can be used for temperature, relative humidity, pH, chlorides, and strain. And these are some of the sensors we developed in partnership with Professor Ken Grattan and Tom Sun's team in City University, London. And then electrical resistivity sensors can be used for moisture movement, chloride ingress, carbonation, chloride ingress, corrosion, and these are sensors developed in partnership with Professor John McCarter in Kirtwat University, Edinburgh. So we can have the monitoring stations, then connecting to remote PC using cloud computing. We get the data, and that data can be used for service life prediction. And depending on how the structure is behaving, intervention strategies can be brought into practice. So the next one then is the building productivity through education and training. So University of Leeds signed a partnership agreement with the Institute of Concrete Technology to offer advanced concrete technology training for graduates. And at the end of that, they get either a PG diploma or an MSc degree. And when somebody gets through that, they can get the MICT, that's the membership grade of the concrete technology. Now, there are 3 routes to admission. One route is the normal degree route for the MSc, but then there are 2 other routes which would be really interesting for people working in the industry. One is called experiential route. Say somebody worked in industry for 20 years, and the last 5 years they worked at managerial level. So that experiential training they got can be written in 1,500 words, and we will do the assessment of that independently by 2 people, and then the admission to this degree is provided. Then the second one is the accredited certificate training. That is, if somebody actually did a number of trainings, CPD trainings, and accumulated training, sufficient training, that also can be used for giving admission. So there are 3 routes for the admission. So what we are trying to do next is work with the Institute of Concrete Technology to develop online education, which will be available all over the world. And we will provide CPD certification, and the credit accumulation can be used for academic and professional qualifications. So concluding remarks then, building productivity can be done through partnership. The partnership can be professional institutions and lens societies like Concrete Society, Institute of Concrete Technology, the American Concrete Institute, RILEM, or possibly the Institute of Indian Concrete Institute and various other organizations. We can work with both domestic and international industries, government agencies, and academic institutions. So this international partnership in construction materials and technologies can result in CPD certificates, module certificates, diploma, degrees, and research and innovation, which will drive more technological advancement, which will be accepted in the industry, and thereby the productivity can be improved. So educating the workforce as well as research and innovation put into practice through this international partnership would help in building productivity. And to do that, we need continuous funding from both government and the industry. We need strategic partnerships such as with the high technology companies and IT industries and R&D institutions. We need global partnerships so that pandemic of the type we faced can be addressed, and we can ensure that there is social and economic development in the countries. So as a concluding remark, there is a social, economical, and technological solution for every problem and situation. Timely and appropriate decision-making is absolutely crucial to the success. As shown here, a triangle wouldn't fit well in a circle, a rectangle wouldn't fit well in a circle will fit well in a circle. So identifying this circle, that is the appropriate technology, appropriate workforce, and timely intervention strategies, all of them would bring productivity of the construction industry. Thank you very much. Any questions?